this presentation on computer studies 451/1, that is the theory paper. I'm your facilitator today, and my name is Angela Musyoki. Welcome. Then let's now look at some of the sample questions that can be tested and how can you approach them. So to start with, I'm going to sample question 16 and then we'll move on. Like for example, possible questions from question that can be tested in question 16. A question on elementary programming theory, like state, give the advantages, all that, define, all that. Like for example, state two language translators, like those are two translators, whereby you can be able to give. Again, let's say like for example, you can be given a language that is written in assembly language, like something that's written in mnemonics, and then you are told to identify the programming language that was used to write that program. Then you should be able to identify that the assembly language that was written, that was used to write that program. So you should expect some theory from that topic, that is the elementary programming. Then again, what else as a candidate should you expect in question 16? Drawing a flowchart can also be tested. Like you are given a scenario whereby you are told this one happens like this. Like for example, there's this question that was tested whereby there was a company that was giving traveling allowance to its employees, whereby each of the employee was given 200 shillings, but those who used private means are supposed to be given 100 shillings extra. And then you are told to design a flowchart that can be used to determine the employee's travel allowance. As a candidate, you should be able to draw that flowchart. Then again, you expect a question that can be, you are told to design a pseudocode. When you are given a scenario, like the one that I've given above, of a company giving allowances, traveling allowances to its employees, and then you are told to design or write a pseudocode. You are supposed to be able to write a pseudocode. Then there are other questions like changing a flowchart to a pseudocode. In this case, where you are supposed to change a flowchart to a pseudocode, this question you are supposed only to remove the symbols, and then again now you write the pseudocode. But as you are removing the symbols here, you are expected to know the control structure that is used so that you can apply it at the point where the control structure comes in your pseudocode. Then you can also be told to change a pseudocode to a flowchart. At this point, when you are told to change a pseudocode to a flowchart, this is now giving your statements symbols, whereby you will have the symbols and you will have the text inside the symbols. Again, here, as you are putting the symbols and the text, you should also be keen on the control structure. Because at this point, if the control structure is used and you don't use it correctly, you end up losing a mark for logic, because your flowchart at that point loses logic. On the same point, when you are writing a pseudocode, changing a pseudocode to a flowchart, again, make sure that the control structure is well put. Again, we have the determining of the output, whereby earlier I said that a dry run, written dry run. At this point, you can use a table whereby you can write the variables in different columns, and then now you start to dry run your flowchart as you write down the variables, the way they are changing. You write down them the way they are changing from one point to the next. Determining of the output here, you should know that sometimes there's a flowchart that will have an output. There's an algorithm that's a flowchart or a pseudocode that will have an output within the loop. If the output is within the loop, remember that you are going to give several outputs. But if the output is outside the loop, you are only going to give the last output. And again, I said, show us the dry run. As teachers, give the dry run. As a candidate, write down the dry run, because the dry run is followed from the first step to the last step. until you give the final output. Then lastly, you can be told to modify a flowchart or pseudocode. Basically, about the algorithms, this is what you should be able to do as a candidate. So points to note when you are designing your algorithms in your questions. There is the point of correct use of symbols at each stage. If it is start, make sure that you use the correct symbol. If it is stop, the same case. If you don't use the correct symbols, you may end up losing a mark on that point. So make sure that as a candidate, you use the correct symbols at each stage. Input symbol, processing symbol, decision symbols, and also the use of other symbols that you need to know to have, like the connectors. Make sure that you use them properly. Then again, as you are doing your algorithms in a question, note that it is important to have a logical flow of events. The algorithm logic comes in here. Are your events flowing in a logical manner, the way they are supposed to follow one another? Don't mix up steps, because if you mix up steps at that point, you lose a mark for logic because your flow chart is not having logic. Make sure that you do the right thing and your flowchart has logic. The logical flow of events is seen. So how? Let's say like we should be able to see the start, should be able to see the input. The candidate should also be able to show the process, decision, output, and stop. And then the control structures. If you use them well, your flowchart will have your pseudocode, your flowchart will have a logic. If you doesn't use them well, then it means that they lose logic. So it is always good to do the correct thing as you are doing your flowchart, as you are doing your pseudocode, and as you continue to do those two. Then points to note again is the procedural dry run in case of output and output. In case of output, I've said output because at a case whereby you have one output and another case you can have several outputs that are maybe within the loop or outside the loop. Let's say like, for example, you can be able to output sum that can be outside the loop. You can also be told to output average and other variables that may require outputs. Again, if it's a number that's accumulating and you're supposed to output and it's within the loop, then the candidate there will show several outputs. Like for example, in this case of a flowchart, you can see the flowchart is there, whereby we have start, redates, then there sum is a process that in the sum, that's a process whereby sum is being initialized to a value 0. Then again we have n that is being initialized to a value 0. Then from there we execute the statements before we make a decision, whereby n is incremented by 1, sum is incremented by n, and then a decision is made, which is n equals to x? If it is true, n, the value of n equals to the value of x, then sum is going to be printed. Else, if it is not true that the value of n is not equal to the value of x, then the flowchart is going to loop. It continues to loop. To continue to loop, executing n is equals to n plus 1 and sum is equals to sum plus 1 until the value of n is equal to the value of x. Then some of the questions can be like, for example, determine the output from the flowchart if x is equals 5. Let's say like when we go back to the flowchart, whereby the value of x is read as 5, then sum incremented, sum initialized to 0, n initialized to 0, and then n is incremented by 1, sum is incremented by n, and then n is equals to x. Remember that we have input n as 1 as 5. So you are supposed now to run this dry run, showing us how the value of n is incrementing. We show again how the value of n is incrementing until the value of n is equivalent to the value of x. And then at that point, then it is now when you display sum, and then the program stops. Again, we have another scenario whereby n, the value of n is read as 7. Again, at this point, you should also, you can continue with the first one, because already you had reached at 5, you continue with the 6 and 7. So show how you are reaching your final answer in this case. Still in this, write a pseudocode for the flowchart in the figure above, figure 3, this flowchart. As a candidate, you are requested or you are required to write a pseudocode. So in this case, it is very good to do your pseudocode in a sequential order of events, the way they are appearing. And in this case, it will be just removing the symbols and then writing what remains after the symbols. And then if you can check here, there is a control structure that comes in. You can see between n is equals to 0 and where we have the statement n is equals to n plus 1, you can see now there's a loop that's coming in there. In this case, in this diagram, the loop here is the repeat until the statements are being executed first and then the condition is being tested last. So in this case, you write start, read x, sum is equals to 0, n is equals to 0, then repeat should come in there. The word repeat should come in there. Repeat. Then which statements are we repeating in this case? We are repeating n is equals to n plus 1. We are also repeating the execution of statements. Sum is equals sum plus n. Then you write the condition now, which should read as until n is equals x. Until n is equals x. Then from there now you write print sum and then stop. So we have just removed the symbols and we have checked where the control structure comes in here. Like for example, there when I was saying that you can be requested to change a flowchart to a pseudocode. This scenario requires you to change this flowchart to a pseudocode. I've just said remove the symbols and look at where the control structure comes in so that you get everything, logic and the correct use of everything. So again, you can be told to modify, like I have said earlier. Like in this case, this question requires the candidate to modify the flowchart so that it can be used to get the sum of integers between 50 and 100. Going back to our flowchart, you can see we need to change the initialization of n. N should not start at 0. N should start at 50. And then we also change the condition because we are actually writing a flowchart that's going to, that can be used to get the sum of integers between. The word between means that it is 51 to 99. So the integers should be summed as 51, 52, all the way to 99. So again, here you have decision in the decision symbol is likely to change. Again, yes, no. So what changes actually here is the initialization of n and the decision, and then we remove the read x. Read x now here we are not reading anything. We are only modifying the flowchart to be able to output the sum of integers between 50 and 100. Another question that was also tested on that was name two programming language translators. As I have said earlier, you can be taught a theory in that, naming, giving advantages, stating, explaining, anything on that topic. So you are supposed to be able, like the two programming language translators, we have compilers, we have interpreters, and we have also the assemblers. The difference is which language do they translate. Then, now that was question 16. Another area that I would want to major on is data representation. How do you approach questions on data representation? Some of the questions in data representation can involve the following. 1, conversion of numbers between one number system and the other number system. Sometimes you can be told to give with a given number of bits. Like for example, if you convert 7, if you convert it to binary, it's going to give you 1, 1, 1. That is the binary representation of 7. Now, supposing the question requires you to give it in 6 bits. So you are supposed to give the binary representation of 7, let's say like in 6 bits, depending on what the question requires of you. Another question on this topic is direct binary additions. You are supposed to be able to add those binary digits together and get the correct answer. When you can be given two clusters, let's say like 1, 1, 1 plus 1, 0, 1, 0. You can be given a case like that, or you can be given 3 clusters or so. So you are supposed to be able to add those binary digits and get the correct answer. There's also aspects of direct binary subtraction. Direct. If you are given 1, 0, 1, 0, you subtract 1, 0, 1. Should be able to carry that binary subtraction and get the right answer as a candidate. Another area of interest here is subtraction using one's complement. And let's say like when we are given a number, let's say like using one's complement, subtract 28 from 56. At that point again, there's a term that has been introduced there, 28 from 56. So you should rewrite the question to 56 minus 28. So the word from there should also be a point that a candidate should note. Don't just start by 28 minus 56 because it's reading 28 from 56. So 56 minus 28. So how do you approach that after writing the question is that you convert each of those numbers to their binary equivalent. Once you convert the numbers to their binary equivalent, you get the ones complement of the negative number, and then you add the 2, you add the binary equivalent of the other number to the ones complement of the negative number, and then if there's an overflow, you add the overflow back to the answer. If there is no overflow, then definitely that one is a negative. The answer is a negative number. So don't start asking, why is this one not having an overflow? It's a negative number. Again, the same applies now to subtraction using two's complement. Start by converting each of the given numbers. If you are given the numbers in decimal, that is in base 10, start by converting them to their binary equivalent. Then from there, you approach your question, that is, you get the ones complement of the negative number, you get the twos complement of the negative number, then you add them together. Overflow, you know, if there is no overflow, you just leave it because it is a negative number. If there's an overflow, it's okay, it's a positive number, ignore. If there's no overflow, it is a negative number. So stop at that point, and that is your correct answer. On this, let's say like, for example, your question can be leave your answer in binary notation. At that point, when you have the binary digits, you are okay. But let's say like, for example, you are told to give your answer in decimal notation, and you are using the ones complement, and the number is a negative number. Your answer is a negative number. What do you do, or how do you approach a question in one's complement? Your answer that you are getting, and it is a negative number, then you recomplement it to get the original number, and then now that digits after recomplementing, it's what you convert to base 10. In two's complement, if the answer is negative and you're supposed to leave your answer in decimal notation, this is how you approach it. The answer that is in binary negative, you subtract 1 so that you get to the ones complement. And then when you are in ones complement, whatever you have, you recomplement it, and then after recomplementing, now you convert whatever you have got to base 10 or to the decimal number system. Then again here, you should expect other theory questions, like for example, what are the encoding schemes, advantages of binary, and even you should be able to explain the number systems. Like for example, a question like, explain or describe the octal number systems. You should be in a position to, let's say, like for example, mention the number of bits that are used to represent a number or a digit in octal number system. You can also be able to say, let's say, like for example, the digits in octal number systems range from, let's say, like 0 to 7. You can also answer it, like for example, saying that it is a number system that represents its digits in base 8. So at that point, you are okay as a candidate. So you can expect any theory question from data representation in computers. Then those are sample questions that I have given them for you. Like for example, state 3 standard coding schemes used in computing and electronic systems. You are able to say there's the ASCII, there's the BCD, and there's the HCD. Those are the standard coding schemes, just stating. So at that point, the candidate, you are okay at that point. Then convert each of the following numbers. Then you are converting 110.101 base 2 to decimal. Show the procedural conversion of the whole number part and the fraction part. How do you approach it? You multiply by their place values, and then you add them together, and then you get your answer. Question 2 on the same of issues to do with converting. 12.6875 base 10. The candidate here should be able to convert either using the place value method or the long division method. You convert 12 and give the binary equivalent of 12. Now the 0.6875, you multiply it by 2 until you get the fraction part becomes 0 or starts repeating itself. And then at that point, you read the bits downwards. So your answer will be the binary equivalent of 12 point, the binary equivalent of 6875 base 2. At that point, you will have followed all the steps and then you get your answer right. Then as I had said earlier, whereby you are subtracting 110.01 from 11.0101. So the key point here, you should be able to see the word from. So in this case, from. So this subtract this number, subtract this number. So you are supposed to subtract 110 point this number. You are subtracting it from this. So you are supposed to rearrange the order of these numbers. So it will be now 110.01101 minus 110.01. So it's a word from here is a word that it's a key word in this question that you should note, because if as a candidate you approach it the other way around, definitely you are not going to get the right answer. Then the next question is using two's complement. Perform the following binary arithmetic, leaving the answer in binary notation. So this one is straightforward. It's already written properly. But what do you do as a candidate? Already this one is already in binary. So The only thing using two's complement, the only thing that you are supposed to do, this number, this binary combination, you change it to 1's complement, you change it to 2's complement, and then what you get, you add it to these digits. So at that point, you will be able to check the answer. If there is an overflow, definitely the maximum number of bits here is 6. So if in your answer you get 6 bits, it means there is no overflow. If in your answer you get 7 bits, it means that the 7th bit to your left is an overflow. So at that point, you just ignore it. So those are some of the questions that you can get from data representation in computers. So you should be able, as a learner, as a candidate, to prepare on the data representation in computers and be able to score. If a question is tested, like for example, if it's a question on section B, and it's all about data representation, that's you should be able to get everything there and score your good marks. Another question is on application areas of ICT. I had earlier mentioned that an answer to a question from this area or from this section must show the technology and use for it to qualify as a right answer. Like for example, if we are talking of an answer like keeping records, computers be used to keep records, you should show the technology that is used to keep records. Like for example, if you are saying use of databases to keep records, that point is right. But if you just say keeping records, that point is wrong. Keeping records by use of databases programs, it's right. The use is keeping records. The technology is database. If we're talking, let's say, like computers being used in places where calculations are required, we should not just say computers are used to perform calculations. How now? Then you should be able to say computers can be used to perform calculations using spreadsheet programs. At that point, you have shown the use, which is performing calculation. You have shown the technology, which is the spreadsheet program. That point, you are okay. Then now on the questions about the application theory, which are questions from 2 work. Like for example, a question from spreadsheets requiring a candidate to write a formula or a function. What should you note at that point? 1, a formula or a function must start. The word must is underlined. Must start with an equal sign. Yes. Any formula written without an equal sign, any function written without an equal sign, it doesn't qualify to be a right function. It doesn't qualify to be a function or a formula. So if you are writing a formula or a function, always remember to start with an equal sign. What else should you note when you are required to write a function or a formula in, let's say, like spreadsheets? Yes. Use of correct function name. If you are using function names, use the correct names. Don't create your own, or let's say like average. Don't write something like AVG. AVG is not a function name. The function name is average. So make sure that you use the correct function name. Then if you are, again, when you are using the correct function name, make sure that you enclose that or wherever you are writing the cell references of your function within the brackets. On the same note, if a formula, now we are away from function, remember functions are the inbuilt mathematical formulas that are used to perform a calculation. And again, you can use a formula that is used and defined, whereby you will use cell references and operators. Use the correct operators and also use the correct cell references. On that, for you to be able to score the right answer on the same, the syntax of writing the formula is of great importance. And then on the use of correct cell references is also of great importance. So now generally, if you'll have done that, you'll be able to score a correct answer. On this example, spreadsheet example, that figure 1, you can see there are the rows there, A, B, C, D, then the columns are there, all the way from column 1 to column 5. There's the item description. There is the number of units, cost per unit, and total costs. Then the questions from that, you are told, write a formula to calculate the total cost of rice. Total cost of rice. When you study your table there, you can see that rice is in column, in row 3. Row 3, we have the label rice. Then the number of units for rice are 6. And then the cost per unit is 145. How do you get the total cost? Know that the total cost is number of units multiplied by the cost per unit. So the number of units for rice are in cell B3, and the cost per unit of rice is it's in cell C3. So this one, you either, the question is write a formula. So in this case, you can have a formula or you can have a function, because a function is also a formula. So you can write, let's say, like for example, you can write is equals, you write the function product, and then you open the brackets, and then the cell references that are therefore multiplying the 2, so that you can get. Again, you can also write is equals the first cell where the item price is, where the item price is, let's say like it's in C2 multiplied by C3. So at that case, you are able to write the correct function. Remember, I have always stressed that a function or a formula must always start with an equal sign. So the correct function here was to be is equals product B3 is equals product B3 full colon C3, and remember the cell references are enclosed in brackets. So make sure that you remember that syntax is also important. If you don't enclose it in brackets, then at that point you start missing the point. Then the same, if you are to write a function, that was a function, then the formula will be is equals B3 multiplied by C3, and at that point you have your correct answer. Then there are other answers, let's say like the second question, the price of our items increased by 10%, and the value 10% is placed in cell B8 using cell addresses with absolute referencing only. So where the value 10% is placed, if you are using that one in your formula, it's going to be absolutely referenced. So make sure that what is to be absolutely referenced, you put it the 10% is going to be absolutely referenced, yes. Then the others are going to be relatively referenced. So whatever is to be absolutely referenced should be absolutely referenced. Whatever is relatively referenced should be relatively referenced. Then the other one is write a function to display the number of cells in which the cost per unit is equal to 110. Actually, where you're required to write a function, it is strictly a function. You can only write a function maybe when the question is requiring you to write a formula. At that point, you can write a formula or a function. But when it's a function, strictly write a function. Like this one is mean is equals mean, and then write a function to display the number of cells in which the cost per unit is equal to 110. So at that point, you write the formula. Then write a function to display the least total cost for all the items. So at this point, it's now when you are going to use the mean function, the minimum function. So at that point, you should also be able to write all your functions and all your formulas correctly. Then on the application theory of database concepts, like for example, this one, whereby you are given two tables. You are given two tables, that is table 1 and table 2, and you are told they are related tables in a database. Then use them to answer the questions that follow, like there's table 1, whereby we have the department code and we have the department name. Then there's table 2, whereby we have the department ID, student's registration number, and student name. In such a case, whereby the questions are like, table 1 and table 2 are related tables in a database. Use them to answer the questions. Like for example, identify the most appropriate primary key for each field. We should go back to the table. Table 1, the appropriate primary key here is department code. Table 2, the appropriate primary key here is the registration number. Department code in table 2 is a foreign key. Department ID in table 2 is a foreign key, and it's the one that is you are going to use to relate your two tables. Your two tables will be related using the department code in table 1 and the department ID in table 2. Then the other question is like, for example, you are told to explain two benefits of enforcing referential integrity. When you are relating the two tables, that is the department code, and then you have the department ID. Now, the department code in table 1 is the primary key, and when you look at these two tables, table 1 is the primary table, and table 2 is the child table to table 1. As I've said that the two tables are going to be related using the department code and the department ID, and when you are creating your relationships here, it's when you enforce the referential integrity. What are the benefits of enforcing the referential integrity in your relationships? You will find, like, for example, one of the benefits is that no field that can exist in table 2 without it being first existing in table 1. No change can be made to table 2 without it being made to table 1. And then again, it will also ensure that any change in table 1 is also reflected in table 2. So those are the two benefits of enforcing the referential integrity. And then finally, questions from word processors concepts, all the way from definition of a word processor to inserting graphics and issues to do with printing. Then DTP concepts are also going to be tested, and then the daily experiences and the emerging issues. So at that point, I have reached the end of my presentation. So I'm now opening for questions to be asked by the candidates.